The topic of this session is multi-threading in C#. C# supports the concept of multi-threading, which enables us to execute two or more parts of a program concurrently. That means at the same time. You need to run programs in a parallel manner to achieve maximum possible parallel kind of execution so that so many applications can make use of the resources at the same time, which maintains proper schedulability by the operating system. So to achieve this, we have this concept multi-threading. If there is a lengthy kind of program, you can split that particular program into threads, and if you try to write and those kind of threads and try to run the program, it will run in a parallel manner at the same time so that it runs quickly. A thread is basically a separate sequence of instruction designed for performing a specific task in the program. Task may represent an operation such as reading data, sending file over the internet, printing some results, or performing certain calculations. So all these, if you have written all these functions to be performed in a single program, that is reading data from the file, a register in the microprocessor is reading data from the memory, and you are sending a file through the network and taking a printout, you are making some calculations. These are different kinds of tasks. The multi-programming operating system handles all these tasks in a simultaneous manner. That's why we will be able to do all these kinds of tasks simultaneously in your mobiles or in your PCs also. We are not waiting to complete a particular program, a program to be completed to start another program, which was being happening in the previous older generations computers, like when we were making use of disk operating system, which is a single user operating system in which a single user used to run the program at a time, and after completing or exiting from that program, he will be able to start another program. This was the kind of situation in those days. A user first he would finish off making calculations, and then he will move on to listen to some songs, and after listening to songs, he would move on to sending files over the network. This was the situation in older generations with single user operating system. But today we have multi-threaded programs which runs this single piece of task at the same time with the help of concept called as threads. Each piece of code that is being running, which is performing some task, is called as a thread. You can make it possible to run those threads in a parallel manner with the help of this concept. The execution of C# program starts with a single thread called the main thread that is automatically run by the CLR and the operating system. From the main thread, we can create other threads for performing desired tasks in the program. The process of developing a program for execution with multiple threads is called multi-threaded programming. The advantage of multi-threading is that it enables us to develop efficient programs that could optimize the use of computer resources such as memory, input-output devices, and time. That is what I told in the introduction part, that it achieves, the different kinds of advantages or the functions of operating system. You have learnt in your basics classes or in your earlier semesters that the function of operating system is it acts like a resource manager which manages all the resources. At the same time, it manages proper scheduling also by making use of all the resources efficiently. This is what the operating system does to help or to achieve that concept. This threading concept has been developed. This concept, we can make use of this concept in our application program also while developing these kind of multi-threaded programs. We can make use of a class or a namespace called as system.threading, which consists of classes and interfaces that are required for building these kind of multi-threaded programs. And these are the classes, important classes, which is present in system.threading namespace, that is thread, thread pool, monitor, mutex. These are different kinds of classes which is present. And these are the properties of the thread class. That means by making use of all those methods, what does your thread class is going to do is, the first property is current thread. To retrieve the name of the thread which is currently running, you can make use of the current thread property. Is alive. It retrieves a value to indicate the current state of thread execution. Is alive means it is alive, thread is running. Thread pool thread is thread pool thread. That means whether the thread which is running currently is part of a thread pool or not. That is going to be indicated by this property, name, property, priority. By making use of this property, you can set the priority for the threads, just like what you set priorities for your programs while scheduling in operating system, or prioritizing the programs while sending through the network or playing through the network. You can specify some processes or threads with highest priority, normal or below normal kind of thread priorities are there, which you can assign, so that the thread with the highest priority level will run quickly, completes its execution, while giving a chance in a least manner to below normal threads. And thread state indicates whether thread which is running currently, whether it has been started or not started, whether it's suspended or it is still running. These kinds of things we can retrieve with the help of thread state. Creating and starting a thread. Thread can be created in C# using the constructor of the thread. We need to pass thread start delegate to the thread class constructor. This method will run the thread So this is the program. The first method of A1 class is running. This message is going to be printed while when you start running the program. Thread dot sleep 1000, and then it will sleep for 1000 milliseconds of time. Then this message will be printed. The time while this message is being printed, in the next moment itself, this message, second method of A1 class is running on T2 thread. This message will be printed. Again, after printing this continuously, it will sleep for 2000 milliseconds of time, and again T2 thread has ended. This message is going to be printed. Here, as you can see on the screen, with respect to the class A1, there is a new object called A, which is running with the help of the start method, and in the next moment this will take up the space, and both the threads will run in a parallel manner.